In this video, we're going to explore topic 6.10, integrating functions using long division and completing the square. So we're going to focus on just the first couple of examples that use long division. So occasionally we may be asked to integrate an irrational expression whose numerator's degree is either greater than or equal to its denominator's degree. So when this occurs, we have to use an algebraic technique called polynomial long division first. So we do know that this isn't a synthetic division thing. We always use long division on this. This is why we learned long division. So I'm going to show you, we're going to do the long division first, and then we're going to go ahead and integrate it. So I would put the numerator inside the division symbol. So 3x cubed plus 2x plus 5, and the denominator outside. And then I ask myself, how many times does x squared divide 3x squared? It goes in there 3 times. Sorry, 3x cubed, it goes in there 3x times. Then I'm going to multiply or distribute. So 3x times x squared is 3x cubed. 3x times 4 is 12x. Then we're going to change our signs, and we're going to subtract. So these guys cancel. And then we've got 2x minus 12x is negative 10x, and then I'm going to drop the plus 5. And then we ask ourselves, how many times it doesn't work, right? How many times does x squared divide negative 10x? It doesn't work, so that becomes the remainder piece of the function. So that means that I have plus negative 10x plus 5 over this mess on the outside. So really what we are integrating, so I'm going to go back to the integration process, is I have 3x plus negative 10x plus 5 over x squared plus 4 dx. So I'm going to rearrange the algebra just a little bit more. I am going to choose to break up this fraction over the same common denominator, which I'm allowed to do. So I've got negative 10x over x squared plus 4 plus 5 over x squared plus 4 dx. Much, much better. So we are going to need a few things here, actually, as part of our arsenal. I'm going to go ahead and break this into 3 integrals. I'm going to kind of cheat on that. I'm going to do this and throw some dx's after that. So on this first integration, I can just integrate it the way it is. It would be 3x squared over 2. So that's done. This next one, I am going to bring the 10 out front. And then I am going to notice that it looks like I have a u sub going on in there. So my u substitution looks like this x squared plus 4. So I'm going to do my u over here. So u equals x squared plus 4, meaning that du equals 2x dx. So I have the x dx. I'm missing the 2, so I need to multiply by 2 on the top and the bottom, and that 2 is going to go inside. So I'm just going to keep working through this middle piece here. So as I'm doing the u sub, let me put this back together. So I've got negative 10 over 2, and then the 2 is going to go inside with the x dx. And then we're going to divide by the x squared plus 4. So now we're actually going to do the u substitution. So when I do the u substitution, I would have just a negative 5. The integral of, for the orange part, I put in a u. For the 2x dx, I put in a du. And then when I integrate this, I know that that's like having 1 over u, which we know is the natural log. So negative 5 natural log absolute value of u. And I'll deal with the plus c at the very end of this thing. So my final answer on this one would be negative 5 natural log absolute value of u, which is the x squared plus 4. And then, of course, I'm going to drop this guy down. He should be on all of them. I'm going to drop him out front, 3x squared over 2. Okay, so that took care of the middle term. Now I have to take care of this term on the outside, so I am going to rewrite it, once, as plus 5 integral of 1 over x squared plus 4 dx. Hopefully you recognize that as one of the arcs. Okay, so that is an arctangent. This is the u squared, this is the a squared. So u is equal to x and a is equal to 2, which means I don't really have any goofiness going on, so it's just a pretty straightforward arctangent. So we know arctangent when I integrate it is 5, and then it's times 1 over a, so 1/2, and then arctangent of u, which is x, over a, which is 2, and then of course our plus c. And I'm going to go ahead and write that down here on the last line, so plus 5/2 arctangent of x over 2 plus c. The only other thing I could do is I could drop these to just regular parentheses if I wanted to.